Hello, this is Miss James, coming back with another video on conclusion writing. This is going to be a more general video to just talk to you about what are the different components and how they're graded. And I'm going to use the series data from the Rtot lab to illustrate. In subsequent videos, I will do both a screencast and a written conclusion for the total resistance lab. Okay. So let's start. The first part of a conclusion should state the purpose of the conclusion. So in this case, we ask the question, how did the number of resistors affect the total resistance if they were connected in series? And because a conclusion is not a suspense or mystery novel, you're going to give up the ghost right away. So you're going to tell me what the answer is as soon as you state the purpose. So if our purpose was to figure out how the total resistance was affected by the number of resistors, I can say that I found that as the number of resistors increased, the total resistance decreased. Then I need to show you artwork. So I want in the conclusion for you to show me what your data tables and graphs look like. Then I'm going to go and I'm going to back up my result with the data. So I'm going to say this is clearly shown in the data table. For one resistor, the resistance was only 221 ohms. But by the time we got up to 4 resistors, the resistance was 886 ohms. This clearly shows an increase in the resistance as the number of resistors increased. Then I'm going to switch to looking at the graph. And I want to talk about the shape of the graph first. So I would say that as you can see in the graph of number of resistors versus the total resistance, the fact that it's a positive sloping line tells me that as the number of resistors increased, the total resistance also increased. Then I'm going to look and try to find advanced analysis. So advanced analysis typically means, let's go back to the data table. If we have percent differences, let's discuss what the percent differences show. And can we analyze the equation of the graph? So for this lab, I would say we found that the way to calculate the total resistance was multiplying the number of resistors by the resistance of the first resistor. And this was a very successful formula. As you can see, our lowest percent difference was 0, our highest percent difference was 1, and on average it was about 0.5%, I think. Let's see, equals average of these guys. Yeah, on average, we have a 1% difference, which clearly shows that the formula works pretty well. We also found this formula by looking at the equation of the graph. We found that graphical analysis showed us that R equals 221.5 times N minus 0.5. The 221 looks awfully like the resistance of one resistor. So we can say that R equals N times R1, where R1 is the resistance of one resistor, and this works really well. Okay, so now we've stated the purpose, we stated the results, we showed the art, we've got the backup. Now we've got to discuss why the results make sense. People lose, this is the most important part of the lab, and people lose a lot of points on it. We want to say that why? We want to ask the question, why should the total resistance increase as the number of resistors increases? When you connect them in series, the resistances come one after the other. So a single charge is going to have to go through each of the 4 resistors to make it to the end. So each time it hits a resistor, it's resistance, it's got to slog through that resistor, and so that resistance increases. In terms of sources of error, which is the next piece on the list, there isn't an awful lot of error in this lab, but you would want to talk about the sources of error that do exist and list them in order of importance. So probably the most important error in this lab is thinking about how well are the resistors manufactured. They've already told you they're within 5%. So a resistor that's 221 is within 5% of the 220 the manufacturer told you. So there's some play in that. How equal are all the resistors? And then there's some accuracy issues with the detector too. The final part is future research. So in future research, you're giving me a new experiment, not the same experiment done differently, a new experiment with a new IV or a new DV. In this lab, you could talk about perhaps doing the same experiment, but doing it on a parallel circuit. Or you could say, in the next lab, I want to hold the number of resistors constant, but change, I don't know, change the total resistance and see how it affects the current. That's a related question, but it is not the same question. Hope that this helps you to write up a fabulous conclusion. Thanks. Bye.